Okay, we want to add these. We want to perform the indicated operations here and simplify. So those of you who are logged in or here in class, what's the first step? Find the LCD. So we have x to the power of 2 plus 3x plus 3x and x and x plus 3. We need to find the LCD among this. So what's the first step to find the LCD, anyone? What do we do to find the LCD in this case? LCD. First thing we have to do is to factor it. Very good, factor. So if I factor x out here, it becomes x plus 3 so this is still x, this is x plus 3. So we need to pick, for the LCD we have to pick x as part of the LCD, and also x plus 3. So this is my LCD. So what I need to do now is to make, I'm going to write this as x times x plus 3 here. Make all these three denominators the same as LCD. The first one is already LCD, the same as LCD, but the second one is not. What do I have to multiply x with to make that, what's missing here? Make it look like LCD. It looks like x plus 3 is missing, so I have to put x plus 3 here and x plus 3 here. You have to multiply it by x plus 3 over x plus 3 because we want to multiply it by 1. Does that make sense? By 1. You don't want to change the original fraction we have here. So the next one we have 4 over x plus 3. So what's missing now? X is missing. Very good. So if I go ahead and multiply this by x over x, so now I have 12 over the LCD, x over x plus 3, plus 7 times x plus 3 over LCD, which is x times x plus 3, plus 4x over x times x plus 3. So you see how I get all these to have the same LCD, so I can add these or subtract them. In this case we're adding. So what I'll do now is I make one fraction here and I write at the bottom of the fraction x times x plus 3. Now I can add what I have at the top of the fraction. So let's go ahead and distribute this here. Very good. We get 7x plus 21. So I have 12 plus 7x plus 21 plus 4x. So if I combine those, what do I get? Anyone, you can tell me what you get. So we get here at the bottom. So we combine this. 7x plus 4x would be what? 11x plus what? 33. Okay, are we done here? Yeah, we're not quite done because it's a simplify. Also, it's a simplify. Okay, we did this. We got the solution to this. Actually, somebody posted for us. Let's take a look at that quickly. Somebody posted the solution for us in the forum. By the way, make sure to post your questions in the forum. Let's take a look at this solution here. Looks like here we're doing the same thing. we are factoring, finding the LCD, we're multiplying the second fraction by x plus 2 over x plus 3, last one by x over x, but we didn't quite finish this, you see that? So we were supposed to finish this by factoring. So what do we have in common here? 11x plus 33. What is the greatest common factor between these two terms? 11. So what do we get inside the parentheses? X plus 3. So you see how we can eliminate x plus 3, right? So the whole thing would be equal to what? 11 over x, and looks like this is a correct choice here for us. Okay, this is complex fraction. One suggestion here is to combine these two first by finding the LCD, make this into one fraction, and then you have fraction over fraction, then change the division to multiplication and simplify. And this would be a hard way to do that. The easy way would be to look at all the LCDs, find the LCD among all these. So here I have RS, R, and S, all of them. Find the LCD. What is the LCD among all of them? Somebody can tell me? RS. Everybody agrees RS. Very good. Okay. Once you find the LCD among every single term, top and bottom of the fraction, then you multiply each term by RS. This is like RS over 1, if you want to call it. So if you multiply each term by that, I can actually add it right here. RS over 1. You have RS over 1. And then here we have RS over 1. What would be the next step, do you think? Anyone? The next step is to reduce. The reason we multiply each term by LCD is to reduce. So this RS reduces RS, right? This would guarantee to get rid of all the fraction when you do that. You have a complex fraction. Once we multiply each term by LCD, then you don't have a complex fraction. This is R reduces R goes to 1, so as S, right? So let's see what we get at the top of the fraction. At the top of the fraction, I would get only 9s to the power of 2 minus 16 r to the power of 2. Everybody agree with that? Number fraction, right? The bottom of the fraction, the first term would give me what? Just 3s, no fraction. Minus the next term give me 4r. See, by multiplication by LCD, in one step, you eliminate all those extra fractions. You don't have complex fraction anymore. So what would be the next step here? To reduce. To factor, very good. So we just factor. How can we factor these to 9s squared minus 16r squared? How do you factor this? That's the difference of squares, isn't it? Remember the difference of squares? You have a squared minus b squared. What is that equal to? Very good. A minus b times a plus b. So in this case, your a in this case is what? 3s. Very good. Your a is 3s. What's your b? 4r. So this would factor into 3s minus 4r, 3s plus 4r, right? Over what? And we got 3s minus 4r. So I can reduce something here, right? What can I reduce? I can reduce 3s minus 4r. There you go. So the whole thing would be equal to what? 3s plus 4r. Do we have that option here? Yes, A. 3s, oh yeah, 3s plus 4r. Not that one. The correct answer would be C. Solve the equation. Here we have 18 over x minus 2 is equal to 1 plus 20 over x plus 2. So what would be the first step, anyone? What do we need to do? Find the LCD again. LCD. We want to find the LCD among all of these. So you can put the 1 here if you want to remind yourself that you have a fraction here also. So anybody can tell me what's the LCD here? Okay, x minus 2, that's right, times x plus 2. What are we going to do with this? What do we have to do with this LCD? Multiply each term, not both sides. Multiply each term, you have 3 terms here. Multiply all these 3 terms by LCD. By doing that, again, we guarantee to eliminate fraction. But before we do that, we have to make a note of some restrictions. For what value of x, this would be undefined. For what value of x, this fraction would be undefined. Anybody? Somebody says 2. That's right. We cannot have, we're going to make a little note here. We cannot have x minus 2 be equal to 0. In other words, x cannot be equal to 2. Always make a little note here. And for the last one, also, x plus 2 also cannot be equal to 0. Does that make sense? Because if we let that equal to 0, then we are going to have undefined. So x cannot be equal to plus or minus 2. So if I find any of these answers at the end, I'm going to exclude them as part of my solutions. So if I multiply each term by LCD, okay, I can write down x minus 2 times x plus 2. I can write it over 1, make it look like a fraction, and multiply that with the first term. Okay, the first term here is what? 18 over x minus 2 equal to, then I multiply the second fraction again with the same x minus 2 times x plus 2 over 1. We multiply that by the next term, which is 1 plus 1. And then we multiply the last term by LCD again, which is x minus 2 times x plus 2 over 1 times 20 over x plus 2. Remember why we're doing this again. We're doing this to eliminate the fraction. So my next step would be to simplify. All right, let's do that. X minus 2 turns to 1. And x plus 2 over x plus 2 turns to 1. So what do I get for the first term, anyone? What do we get for the first term? 18 times x plus 2, very good. Equal to, what's the second term? X minus 2 times x plus 2. And the last term, 20 times x plus 2. You notice that I don't have any fractions anymore, right? Now this equation is a linear equation, is equivalent to this equation. So which one is easier to solve? This one, right? Isn't this a lot easier to solve than this one? So the step is to multiply step by LCD. In one step, you would eliminate the fractions. Now everybody should be able to solve this easily, right? So if I distribute this, what do I get? 18x plus 36 equal to, now we already know this is the difference of square, so this should be equal to what? X squared minus 4, right? Remember that? A minus B times A plus B with A squared minus B squared. So I didn't have to multiply term by term. Even if you did that, you would get this. And then the last term would be what? 20x minus 40. Let's combine like terms. Do you have anything I can combine at the right-hand side? What do I get if I combine the numbers on the right-hand side? Negative 44. And what if I move both of these to the right and make this 0, and then on the right-hand side I would get minus 18x. Does that make sense? Minus 36. I'm really subtracting 30x and 18x. So I want to make this a standard form so I can start working on factoring. So I have x squared here. If I combine all the x, what do I get? That would be plus what? Just 2x. If I combine all the constant, what do I get? Negative what? 80? Yeah. Good. Alright. Equal to 0. To solve this, what do I have to do? Factor them. Is it factorable? If it's not factorable, we can use quadratic formula, but let's see if it's factorable. Can somebody tell me what are you going to select here? 10 and 8? 8, if I use 8 and 10, the product would be 80. And if I subtract this, I get 2, right? So I want to have plus 10 minus 8, so I would get plus 2, and then the product of minus 8 and plus 10 is indeed is 80, negative 80. So there we have it. X minus 8 is equal to 0. So what is x is equal to? 8. Or x plus 10 is equal to 0 means x is equal to negative 10. Can I pick both of these answers as a solution? Neither of them are 2 or minus 2, so I'm going to box this. We can always go back and check your answer by plugging the numbers here and convince yourself these are the correct answer. So which one should I pick? A, B, C, or D? B. Now it looks like B is the correct choice here. Okay, there's one question here from one of the students saying that why the LCD is x minus 2 and x plus 2. So let's take a look at that. So if I want to find the LCD between 2 and 3, okay? Could use a little chart here. Okay. Well, 2 is the prime number. 2 consists of 1, 2, and 3 is the prime number. Consists of 1, 3. So the LCD here would be we're looking at these prime numbers and pick the largest of all. Among the group of 2, we have 1, 2, no 2, so we're going to pick 1, 2. That's part of my LCD. And among the group of 3s, I'm going to pick 3. That's one way to look at how to find the LCD, which is equal to 6. Now the question is how to find the LCD among x minus 2 and x plus 2. So this would be kind of the same idea. If x minus 2, x plus 2, these are different terms. If you look at this carefully, what we're doing here is we are looking at see how many x minus 2 we have or how many x plus 2 we have. We just have expression instead of having a whole number. So in this case, well, x minus 2 consists of only one x minus 2 here, only one x plus 2 here. So to find the LCD, we do the same thing here. We look at the group of x minus 2. We have one x minus 2 here, and now I have an x minus 2. We're going to pick that as part of my LCD, just like we did with 2. And among the group of x plus 2, well, we have to include this as x plus 2 as a part of the LCD. So you see how to find the LCD between the expressions now? So that's how you do that. So if you were going to find, let's take a look at another example. If I were going to find the LCD among some numbers here, I'm going to make this 3 this time. So let's say I have among group 2, 3, 5. So let's say I have 2 2s here, 1 2 here, 1 3 here, 1 5 here. So let's say we want to find the LCDs among these numbers. So let's say I want to know what LCD between 4, 6, and 5 is. So if I break the number into its prime number, so among the group of 2, you have to pick 2 2s because that's the largest of all in this group. So 2 2s. And then, well, you have to pick 3 here. There's no 3 here. That's part of my LCD. And so as this one would be 5. So what do we have here? 4 times 15. So what's LCD here? 60. So the LCD is 60 among those numbers. So if I were going to find the LCD among x minus 4, x minus 6 square, x plus 5, and then let's put some stuff here, x plus 5 square here, and then I'm going to put also x minus 6 here. If we were going to find the LCD among these 3, so you could make your chart. But in this chart, you want to know, well, how many x minus 4 you have, how many x minus 6 you have, how many x plus 5 you have. So in this case, if you group them, you can see that you would have, well, in this group, we have 1x minus 4, 1x minus 6. There we have 2x minus 6 here, square. Here we have 2x plus 5 here, this is square, and then 1x plus 5. So if we're going to find the LCD among all those, so from the first group you have to pick x minus 4 as part of your LCD. The second group you have to pick x minus 6 square, and the last group you have to pick x plus 5 square. Pick the largest of all. So just like dealing with the whole numbers, here we have expression when you factor them, and that's why the LCD among x minus 2 and x plus 2 would be x minus 2 times x plus 2. Here we want to solve p minus a over 1 plus rt. We're going to solve this for r. So let's go ahead and write down what we have here. I can write this as p over 1, make this like a proportion. Or you could multiply each term by LCD as well. Or you can just cross multiply. Since this is a proportion, I can cross multiply this. This would be the same as E times 1 plus RT. And this, if this were a proportion, you could multiply each term by LCD to eliminate that fraction. So this is what we have so far. So this one here is equivalent to this right here. Same thing. So to solve for R, remember we're solving for R here. So let's use this different color here. This is R. Okay. So we want to isolate this R. Can somebody tell me what would be a next step here? How do you isolate this R? What do we do to eliminate everything else attached to R? Divide by what? No, not divide by R. Divide by P, right? We can eliminate the P if I divide both sides of the equation by P here. You can see that I would get rid of that P. I can move the P to the other side of the equation, in other words. Okay, so we get 1 plus, remember we're still looking for isolating R, so let's use a color here, R. And then P here is equal to A over P. Question on that, anyone? So how do you eliminate the other terms? What would be the next step, do you think? Subtract. Very good. You eliminate the constant. If I subtract -1 from both sides of the equation here, then I would get RT is equal to A over P minus 1. Does that make sense? So how do you solve for R now? We can divide each term by T, right? Or multiply each term by 1 over T. Does that make sense? Okay, so if I multiply each term by 1 over T, we have 1 over T here, 1 over T. So this is how you isolate R. So R then would be equal to A over P minus 1 over T. Does that make sense? So if any of these are my choice, can I pick any of them match my solution here? Not really. So what do we have to do? It looks like this is one term. All of them, all these three are one term. So I have to combine these two to see which one would match as these, right? So how do you combine these two? The LCD again. What is the LCD between those two? The LCD is TP, right? LCD would be TP. So I need to multiply the second fraction by P over P, so I would make it the same as TP here. And then now I can combine them. That would be A minus P. Does that show me any of those choices now? Looks like A is A minus P over PT or CP. So this looks like the correct answer there. Okay, here we have a word problem. The amount of time it takes a swimmer to swim a race is inversely proportional to the average speed of the swimmer. So let's set up a variable for this. So we're going to set up the time. We're going to call this t. So if t is equal to, when it says inversely proportion to the speed, so I'm going to call this v, like a velocity, so it doesn't confuse us with s. Sometimes they look like 5 when you use s. Okay, so because we say t is proportion to, inversely proportion to the speed or velocity v. So when it's proportion, there's some factors involved. That factor here, we're gonna usually call k for that. Use the factor k. So you don't really have to memorize this. You have to read the question carefully. If it's a proportional, inversely proportion, or directly proportion, you set up the equation with this factor of k. So if this were directly proportion, that would be t is equal to k times v. Because it's inversely proportion, then we write this as t is equal to k, some factor k times 1 over v. 1 over v is inversely proportion. In order to solve for k, we need to read the question and see if you know any values, initial values for t and the speed v at that moment. So let's read the question, the rest of them. It says, a swimmer finished a race in 30 seconds. So if the time is 30 seconds, the speed or the velocity at that time is equal to what? 5 feet per second. So we just call it 5. So we can easily solve for k. Solve for k. So we need some initial condition to evaluate this constant k. So how do you solve for k, anyone here? You multiply both sides by what? 5. I multiply both sides by 5. Then I would get k. So what is k is equal to? 150. So now I know k is 150. I can write my formula as t is equal to 150 times 1 over v, or 1 over speed. So now I can solve for any other conditions I want. Here that wants you to find the average speed of the swimmer if it takes 25 seconds. So they're giving you the time is 25. They're asking you to find the speed or the velocity. So here I want to solve for v. How do you solve for v here? Multiply both sides by what? You can it's not kind of like a proportion here. If you cross multiply that, you get 25 v is equal to 1 times 150, right? Does that make sense? It's kind of like a proportion. It's 25 over 1 is equal to 150 over v. You can look at it as being a proportion. It's the same thing. These two are exactly the same, really. Okay, so how do you solve for v? v is equal to 150 over 25. So what is v is equal to? What's the speed? Dividing 25 into 150, what do we get? 6? So forget the units. It would be 6 feet per second. So which one would be the right choice here? C. Okay. Use the rules of exponents to simplify the expression we want to write the answer with the positive exponents, and we're assuming that all the variables represent positive real numbers. Let's kind of review our rules for exponents. If I have a to the power of n times a to the power of m, can somebody who's here today tell me how would you multiply this? That would be a to the power of what? Okay, somebody says nm, someone says n plus m. So make sure you remember this is simply adding the exponents, right? N plus m. If you have x squared times x cubed would be x to the power of 5. You add the exponents. So in this case, as you see here, you have x to the power of 1/2, x to the power of 3/10, x to the power of 2/5. So I can combine these three using the same rule, right? The only differences are m and n are not whole numbers anymore. They are, looks like they're fractions. But we know how to add fractions, so let's go ahead and see if we can use this property to combine what we have at the top of the fraction. So if I have x to the power of 1/2 times x to the power of 3/10 times x to the power of 2/5. So according to this property here, this whole thing would be x to the power of what? What are you going to do with these fractions? You add them up. 1/2 plus 3/10 plus 2/5. How do you add fractions? You find what? LCD. What's the LCD? 10. So I need to multiply the first fraction with what? 5/5, not 10, 5/5. Second one is already 10, I don't have to worry about the second one. The third one, I have to multiply the third fraction by 2/2. So now I can combine these. Then I would have x to the power of, so it would be 5 plus 3 plus 4/10. Does that make sense? So this whole thing would be x to the power of what? What over 10? 12/10? Can I reduce that?
Yes.
What do we get? Half of 12 is 6. Half of 10 is equal to 5. So the top of the fraction would give me x to the power of 6/5. But just simply adding those fractions. Does that make sense? Now, the bottom fraction here, we're going to use the other property. A to the power of n to the power of m. Anybody remember how do you simplify that? That would be a to the power of what? What do you do with the exponents? Well, now you multiply them, yes. So, over here, the example would be x to the power of 2 to the power of minus 1/2. That would be the same as x to the power of what? 2/1 times minus 1/2, right? Which is equal to x to the power of? Anyone? -1. Not -1. Okay, so x to the power of -1. Everybody with me so far? Question on that? Okay, the last property, if I had a to the power of n over a to the power of m, what do we do with these exponents? That would be a to the power of what? Subtract, very good, n minus m. So in this case, I have to subtract them. That would be x to the power of 6/5 minus 1. So that would be x to the power of 6/5 plus 1. The LCD is 5. I'm going to multiply this by 5/5 then. That would be x to the power of 6 plus 5/5, which is equal to what? X to the power of 11/5. Now, you notice that the exponent turns out to be positive, so what would be the right choice here? A, B, C, or D? A, right? Write the radicals. Assume that all variables represent positive real numbers. Here we have x to the power of 4, y to the power of 4, and the whole thing is to the power of 1 over 5. Okay. Let's take a look at some properties here. If I have nth root of a to the power of m, anybody remember how to write this as exponents? That would be a to the power of what? Where the m and n goes? M over n. Very good. Remember that. Write this down somewhere. Make sure you remember this. So if I have fifth root of a, that would be a to the power of what? Remember, m is 1 here, right? 1 over 5, right? The second root of a would be a to the power of 1 over 2. So it looks like this problem here, we're going to have 1/5 here. That means we're talking about the fifth root of whatever you have here. Does that make sense? Fifth root of this. So it looks like if I, and then raise everything to the power of 4. Or we can look at this as another property we have, make it a little bit more clear. If I have a to the power of n to the power of m, we know that we have to multiply the exponents like that. It would be n times m. So if I go ahead and simply apply this property here, I can write this one as x to the power of 4 over 5 times y to the power of 4 over 5, right? So each of these, if I want to write it in terms of its radical, means fifth root of x to the power of 4, right, according to this. This means fifth root of y to the power of 4. So what we really have here is fifth root of x to the power of 4, y to the power of 4. Okay. There's another property that would be pretty handy to use. If I have nth root of a to the power of m, you can write this as nth root of a and then raise it to the power of m. So in this case I can write this as, this is really the fifth root of x, y raised to the power of 4. And it looks like the correct answer here is B. Express the radical in simplified form, assuming that all variables represent positive real numbers. When you have a cube root of any number here, so you're looking for factor of 3's here. So remember, if I have a to the power of 3, if I cube root of that, anybody know what this is equal to? Okay, remember, if I have a nth root of a to the power of m, that is the same as a to the power of m over n, remember? So if the roots and the exponents are exactly the same, so that would be a to the power of 3 over 3, which is 1, right? So that would be equal to 1. Does that make sense? So if I have 3 of a kind under this radical, and the root here is the same 3, then you can eliminate the radical, and you have that. But everybody know what is 4? Everybody know what's the square root of 4 is equal to? What is the square root of 4 is equal to? 2. Now remember, we have 2 2's underneath this. This is 2 squared. If you use the same property here, okay, this would be 2 to the power of 2 over 2. When you have a square, this means 2. So that's why it's equal to 2. So the goal here is to have 3 of a kind here. Do we have, if I break negative 64 to its prime numbers, what do I get? How many of numbers, the same number we get multiplied together 3 times, you get 64? Somebody says 8, somebody says 4.
Negative 4.
Negative 4, right. Negative 4 to the power of 3, that gives me minus 64. So we do have 3 4s here. So if I separated this, just this part here, this is like cube root of negative 4 to the power of 3. So what is this would be equal to? Just negative 4, right? According to what we just talked about here, right? Okay, so let's take a look at the next one. Is 8 a factor of 3? No. What is 8 divided by 3? We cannot divide 3 into 8, right? We cannot. But portion of this is factor of 3. So I'm going to write this 8 to the power of 8 to the power of 8. I'm going to break it to 8 to the power of, what number would be factor of 3 which is less than 8? 6, right? 6. And then the extra would be the 2, right? So 8 to the power of 8 is really 8 to the power of 6 times 8 to the power of 2. So if I write it this way, part of this would be perfectly cubed. So at least I can take this portion out, this portion here. So what is this would be? This portion I cannot do much because I don't have 3 of a kind here. But this would be a to the power of what? 6 over 3, right? According to this, m over n, this would be 6 over 3. So that would be 6 over 3, which is 2. But this portion I have to leave under the radical. So far I have minus 4, a to the power of 2, this came out of the radical, but this stayed under the radical. I can do the same thing with b to the power of 5. So how do I take b to the power of 5, break it to what? b to the power of 3 times b to the power of 2. Part of these is perfectly cubed. You can write this as b to the power of 3, b to the power of 2. These are all cube root. So this would be come out as just b, right? But b squared stay under the radical. So let's see what came out of the radical. Negative 4, a squared, b, these all came out of the radical. What stayed under the cube root, the radical? A squared, b squared. So which one would be a right choice here for me to pick as the answer? A. find the distance between the pair of points. We have 2 points. We want to find the distance between those two. We need to know the formula. Somebody actually posted a solution in class. Let's take a look at the solution that is posted. And this looks like a right solution. We have a distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared. So you have to pick these 2 points and label them point 1, point 2. So if you call this point 1, this would be x1, this would be y1. If you call this point 2, that would be x2, y2. Just simply substitute those numbers into this formula and you find the distance. Now, if you find the 2 points, let's kind of actually look at the 2 points here in the number line to make a better sense out of this. So I'm going to locate those 2 points, 5 and -3. So on the x-axis, I'm going to move 5 units. 1, 2, 3, 4, 5, -3, 1, 2, 3. This would be, I'm going to call this the first point. And the next one would be 3 and -7. So 3, this is 3 and -7. Should be this point here. So we want to find the distance, -7, this is 3, this is 5. We're going to find the distance between these 2 points. If you form this Pythagorean, use the Pythagorean theorem. If you use this if you form a right triangle here, you can see the distance that we have from here would be -3, and this would be -7. So you see the distance, the hypotenuse would be the distance here. So the hypotenuse, the distance, or D, call it D, is equal to D squared is equal to this height here. I'm going to call this a height, and this is a base. So the distance here would be squared is equal to h squared plus b squared. This is a Pythagorean theorem. Everybody remember the Pythagorean theorem? When you have the right triangle? So the distance must be square root of h squared plus b squared. And that's where this formula comes from here. You see, h, or the height, would be the difference of y2 minus y1. H is really y2 minus y1. And the base here would be x2 minus x1. This is difference of the base here and difference of the y here. So that's where the formula comes from. If you forget the distance formula, you can actually locate the 2 points like I did here. Just form a right triangle here and just evaluate the hypotenuse using the Pythagorean theorem, and you can kind of see how this formula come about. Again, you can use any of these point 1 or point 2, doesn't make a difference here. So it looks like you're saying y2 is equal to -7, so we're saying that point 2 is equal to 3 minus 7. So this would be y2, and this is x2, and we're calling the first one point 1, 5 and -3. So this would be x1, that would be y1. So that's how you can substitute the numbers here and find the distance. And then don't forget you have to simplify this. It would be 20. If you break 20 into its prime numbers, 4 times 5, square root of 4 would be 2. Then we have 2 radical 5.